Thank you, for the kind introduction. Today I'm going to talk about the latest research project in my laboratory. And the title is the Towards Understanding the Relationship Between the Structure of Consciousness and the Information. And can you hear my voice clearly? Fine. Okay. All right. Let me start from the background of the consciousness research. What is the problem of consciousness? Briefly, it started with Descartes' principles of philosophy, influential idea of the cogito ergo sum. I think therefore I am. And the important thing to note is that Descartes started to separate the brain, objective things, and the consciousness, subjective things as separate things, and that's the start of the dualism. And Galileo and others took this kind of tradition, and then they basically said that science should focus on the objective world, and subject stuff should be outside of the science. And following that, Newton further pushed the idea, and science should be focusing on the nature, which is written in mathematics. And he wondered whether consciousness can ever be mathematically tractable. And in fact, along this line, Kant, who is a very famous philosopher, also said that problems in mathematics, consciousness is basically impossible to mathematize. And also, we can't also accurately observe it. So that's the reason why he thought that, science of consciousness is impossible. However, starting around 1900s, Wundt, Fechner, and James and others started a project called psychophysics, which is mathematics of consciousness in the beginning. But at that time, the brain was completely left as a black box, and that led to the behaviors. And this basically led consciousness to be the outside of psychology. And then since 1990s, due to the brain imaging, various scientists started to identify neural correlates of consciousness, and that started to this flourish of consciousness and neuroscience. And by now, I would say that the more than 10 approaches to study consciousness exist. And from philosophy to neuroscience, Chalmers, Dennett, and so on. And also Francis Crick and Koch, who proposed a neural correlates of consciousness, Lame, Tononi, and then Frisson, Hopi, and the Penrose, Hameroff. And even recently, AI approach has started up here, Benjo's consciousness prior. And what I have been contributed to this field is to introduce several methods called continuous flash suppression, or relationship between attention and consciousness, and recently no report paradigm and category theoretical approaches. And recently, consciousness research has been accelerated through the adversarial collaboration funded by Templeton Foundation. And this is a paper depicting a recent approach to make the hard problem of consciousness easier by letting the two theoretical predictions, like a global neuronal workspace and integrated information theory, to make a specific prediction about the outcomes of the experiment, and then make the data available openly, and then to check the sort of the accuracy of the prediction through the pre-registered theoretical predictions. So, this kind of method will allow the consciousness science to progress much better further. So in summary, the background is that the consciousness research is, getting accelerated and getting a momentum. And to understand how the world works, we need to understand the relationship between consciousness and the brain, which has been left out since the time of the Galileo and Newton. And scientific research of consciousness is already kind of established, but also, latest major upgrade includes comparison across theories with the registration. So our current research in my laboratory focuses on establishing the gold standard of consciousness research through the Qualia structure paradigm. What does it mean? So my lab is trying to establish a gold standard of the so that we can actually make a tangible step towards a solution of the problem of Qualia. And in fact, although I said that there are more than 10 approaches or theories to attack problem consciousness, all theories have not faced up with the difficulty of quantifying qualia or consciousness, contents of consciousness. So instead, what we propose is a novel paradigm we call qualia structure to quantify qualia based on the category theory. And we are currently trying to establish mathematical and physical method to do this. And to start with, we are focusing on the visual qualia that it should be applicable to other qualia as well. So by the problem of qualia, what do I mean? Throughout the conference, I think you'll see that many people use the word consciousness to mean different things, but the important two distinction is a level of consciousness, such as from coma to awake, and another one is qualia or contents or meaning or quality of consciousness. And what I mean is really in this talk, I'd focus on the qualia, contents part of the consciousness. And although the qualia is the source of our knowledge, but qualia are quite weird thing, if you think about. And according to Dennett, it's characteristically impossible to study, and because of its four distinct characteristics. One is the ineffability that you cannot actually describe in language, and enigmatic, it's unclear what the biological function is through the evolution, and private, it's totally subjective, and you cannot actually share that directly with other people. And the same, similarly, intrinsic, it is a property that you can experience from inside, but not observed from outside. So in fact, because of this, problem or property of qualia, traditional neuroscience has completely avoided the problem of consciousness altogether. And in fact, most of the conventional neuroscientists have focused on either sensory inputs or motor outputs on one hand, and then relate how this kind of external world is related to the brain activity are. So the revelation of the function that changes sensory input in the response is the conventional neurosciences targets. But Crick and Koch introduced neural correlates of consciousness paradigm since 1990s, which focused on the other types of the relations. So here they propose to use the particular types of the stimuli, such as Metcalfe cube here, which stays same as a stimulus outside, but it induces the changes in the brain activity over the time. And as a result, subjective experience actually changes. In the case of the Metcalfe cube, left side front or right side front, kind of, conscious perception alternates over the time. And then, because we can fix the sensory input side, we can see the response and its relation to subjective experience only. So this function relationship between response and the conscious contents, G, is the target of the consciousness research. But so this is actually a great progress, and we are making a lot of progress with this kind of paradigm. And most of the 10 theories I kind of mentioned in the beginning is focusing on this type of the paradigm. However, this actually makes it also difficult to study qualia or giving up qualia altogether in some cases. The reason is that this type of the strategy requires some kind of stimulus that can induce the type of the report that is almost binarized by design. So Metcalfe cube can induce the report of left or right, or if you use masked stimulus, it could be seen versus unseen. But the important aspect of the qualia is that it's quite meaningful and also rich, and there are many aspects at the same time. So that's the sort of the quite interesting or quite enigmatic aspect of the qualia. But this approach, NCC approach, binarizing qualia, we lose a lot, too much maybe. So what can we do with that? One particular promising kind of approach has been already suggested by philosopher Chalmers or neuroscientist Tononi as well. So that both of them has actually proposed that the structures are the important kind of thing. In the case of Chalmers, his proposal was a psychophysical coherence analysis, but what exactly it means is unclear. And on the other hand, Tononi has been proposing that it is the maximally reducible conceptual structures mix, for short, that is corresponding to conscious experience. But his theory is known to be very complicated. And so what I have been working is this mathematician Hayato Saigo, and he and I, and also philosopher Taguchi has proposed that maybe category theory, which is a tool in mathematics, can deal with the structure, because that has been actually developed to deal with the structure in the first place. And recently, we have been pushing this kind of idea to the extent that we arrived at this specific proposal using the Yoneda lemma in category theory to quantify qualia through relationships. So the idea here is that quantifying qualia structures through massive relationships among qualia. So the idea is that qualia itself is very difficult to characterize. So if you are asked, for example, what do you feel about this red, and then all I can say is like, oh, this red is very similar to the red that I had yesterday or this morning or whatever. And I can only rely on metaphor or very weak explanation. I can't be never satisfied about what the red is that I'm experiencing. However, if you look into the other field of the research, it turns out that the situation where you can't actually describe one thing with a single word is abundant. And for example, in the case of the personality, if I try to explain or introduce myself, I could do that by listing my property of personality X, Y, Z. But also, it's easier. It's in some cases that if I introduce my personal relationship with my wife or children or friends or other scientists and so on. And in similar thing happens for the meaning of words. Shu, who is the founder of the modern linguistics, also pointed out that meaning of the words are defined through the relationship with the other words. And if that's the case, then the definition of one word depends on others, and that word itself depends on others. So it kind of doesn't make sense, but that's the way meaning of the word is, in fact. And also, similar thing can be said about the properties of the animals or plants in the ecosystem. If you try to characterize panda, for example, then you need to characterize not only how the panda looks like, but also where he lives or what it lives, eats and things like that. And in other fields like cosmology, black holes are not observable on its own because it absorbs everything, including lights. But its interaction or relationship with the surrounding objects can be quantified and measured and predicted. Similarly, even in mathematics, there are many infinities, and the infinity itself cannot be dealt with, but its relationship can characterize and classify different kind of infinities. So in summary, what I wanted to say was that there can be a way to deal with this type of the situation where you can't directly define one thing in its own through the relationship. And that's exactly the kind of the proof that is given by the category theory. The Yoneda lemma is like a pre-theorem or a major theorem, says this quite a complicated kind of equation, home of home A to something with respect to F is isomorphic to F of A. It doesn't mean anything to you, most of you. But what it means is that as a consequence, HA, which means that the A's relationship with others, and the HB, which means that the B's relationship with others. If those two things two relationships are isomorphic, then A and B are also isomorphic. That means that that can be now applied to the neuroscience or psychology or online experiments that introduce myself we are doing. So instead of directly trying to identify or characterize red as itself, we are going to ask how the red is related to or similar to this purple or pink or orange or red and so on. And then if the two things relationship with the others are same, then we can see that, these are probably the same thing. And the intuitive example of this, Yoneda lemma type approach to the Qualia is that these, two types of the shades A and B here. So in terms of luminance, A and B here are the same, but it doesn't look the same. Qualia-wise, they are different. And what the Yoneda lemma actually predicts is that if the relationship between A with others and B with others become the same, then A and B should become the same. And in fact, here, A relationship to I, like A and I is definitely, brighter, is already different between B and I's, the relationship. B and I look kind of similar. So if you remove the component like I or two and so on, that makes the relationship between A and others and B and others different. Then the difference between A and B starts to become smaller and smaller and smaller. And eventually, if you remove everything around surrounding, then A and B now looks the same. So that's the sort of the phenomenological prediction of the Yoneda lemma. And how can we use the Yoneda lemma in research? That's the next question. And then for that purpose, what we are using is the color qualia at the peripheral, vision. And why do we care about that? Because it's the primary kind of contentious target of the debate in the philosophy and psychology. So if you have opened the textbook in psychology or neuroscience, you might have encountered this kind of figure. And what it means is that our retina, back of the eye, has a different kind of density of the photoreceptors for rods that is mainly responsible for the vision at the dark kind of environment, and cones, three types of cones that are responsible for color experience. And what this figure says is that at the zero eccentricity, exactly where you are looking at one point, then the density of these cones are extremely high. However, it falls off really sharply, and by like 5 degrees off from where you are looking at, it's almost like nothing, and it stays really low. And this kind of goes against with your own color qualia, right? Most likely, many naive people, including psychologists or philosophers, usually feel like qualia across all the visual fields, including around here. If you are in the room, then maybe you are feeling like blue here or red here, things like that. And outside, you may feel like a blue sky. However, some people have said that based on this kind of receptor density, that just cannot be possible, because what we are seeing is based on this so few number of receptors. And it's almost like a light in the refrigerator. Refrigerator, if you open them or if you attend to it, then you see the light, you see the color. So this is the same thing. You feel like your field is filled with the color, but that's always because of the fixation or attention. When you look for that, you can see it, but it's almost by default. It's filled in by the memory or expectation or something really illusory. That's what some of the philosophers and the psychologists have been claiming. On the other hand, some other people say that no. If you feel color in the experience periphery, then that's the basic starting point. Qualia are the starting point of the reality. So there must be something wrong with this conjecture. starting from the retinal ganglion cells, receptor cones, kind of, density. And so if you can adjust your, distance to this display, you might be able to adjust the size of the, fingernail to the location of this, the size of this figure on the bottom left. And then at the arm's length, it's known that the fingernails is roughly like 1 degree visual angle. So, roughly around here, if you don't move your eyes, it's already 5 degree visual angle. And you're not supposed to see, color if some of these, illusionist type people are correct. But it's probably, hard to believe or, hard to convince yourself that you're not seeing this color, real in real. So what's going on? To address this question, what we did was that to use this known color structure, if you use the isoluminant color, then unlike the wavelengths distribution that starts from ultraviolet to the blue, and then goes back to green, and then eventually red, and then infrared, invisible light, this kind of one-dimensional wavelength is within our brain, color areas, somehow it's kind of united into sort of the ring, so that the red is above to the purple, and then it forms like this kind of shape, and that predicts a similarity relationship between the colors. And my postdoc Ariel Zeleznyko Johnston decided to use this technique or structure, known structure, to test whether the peripheral color structure and the foveal color structures are the same or not. And then this is his experiment, and then showing two colors at one point, and then asking people to rate the dissimilarity from 0 to 7. And then because we always presented the stimulus at a random location, at a random color, and also basically impossible to memorize or impossible to expect or fill in. And then we measured center or center peripheral or peripheral kind of pairs of the similarity in a massive manner. And then what happened? So in short, basically central pair or central peripheral pair or peripheral pair, all of them basically produce exactly the same kind of structures. So that means that what we are seeing in the fovea central is essentially the same as the peripheral vision as well. So this is there is a reason why this is the case, but for the short term time, if you're interested, I'll explain it later. But basically, it is compatible with the idea that our receptive field of the neurons increases in the periphery and then compensates for this loss density of the cones. And we are testing this with a very far vision with a new display type of device in Japan. So the next step along with this kind of line is to establish this Qualia structure, not only through the psychophysics, but also to apply that with the brain imaging and also brain recording, brain manipulation, and then extract the information structure out of that. And then eventually to try to find a relationship between the information structure, which is abstracted from the brain, to the Qualia structure that we experience in the phenomenological world. So, for example, what we have been doing is that using exactly the same kind of stimulus and also task inside fMRI scanner or EEG, and then in the case of fMRI, we have a better a spatial resolution, but a very bad time resolution. And in the case of the EEG, we have a good time resolution, but we don't have a good spatial resolution. And then try to find out the structure in terms of this response pattern similarity. And then in the case of EEG, so for example, what we can find is that just after like 100 milliseconds after presentation of a patch, then it starts to show that some part of the brain seems to start to show the kind of the response pattern that looks like the behavior, similarity response pattern. And now, because we measured similarity response and behavior EEG from the same person, we can find this type of the very early response that we are looking at whether this is generalizable across people and so on. But so far, the relationship between this EEG data or fMRI data with our similarity itself is too weak. And eventually, what we want to do is to extract relevant kind of information structure that purifies and discards all the unnecessary non-conscious activity, and then trying to extract the relevant information structure that ideally correlates with our conscious Qualia structure much more strongly. And for that reason, we are trying to use one of the most quantitative theory called integrated information theory to compute this ideal information structure out of the brain structure and the activity. But I'll skip these details of the mathematical part of the study. So in the end, what we want to do is to measure the neural activity or manipulate the neural activity, and then extract the information structure, and then also extract or collect the behavior or Qualia structure data from the subject as well, and then try to use the category theory to see whether there can be any kind of isomorphism or similar kind of structure between one to the other. So in summary, what we are trying to do is to quantify consciousness through the relations. That's a kind of a new idea, I think. And then trying to extract information structures from the brain, and then utilizing different kind of mathematical or information technique to analyze these learns. So eventually, just briefly, I think these types of the approach can lead to understanding of others and other species through the understanding of the Qualia. And then that can be eventually useful to study or construct either AI or robotics that maybe possibly contain have some kind of Qualia in the future. So the fundamental problems of consciousness require, I believe, interdisciplinary approaches, and so that's the conclusion of my talk.